Okay, hi guys, and welcome to the 28th, I think, edition of Wrocław Meetup. Okay, and who are we? We are a bunch of people who are interested into Rust. We are interested into sharing knowledge, and we want to talk about Rust and drink some beer in the meantime, obviously. But you know, we are community-driven, and you are the most important people here. But to make things work, we need some organizers, so we can gather talks, speakers, and so on. So I am Bart from Confio, and here is Michał from Taumatek. If you have any questions about organization or anything, just ask us. Maybe if you have any comments, just find us, and so on. One thing, we are speaking English here mostly because we know that sometimes here are some English, non-Polish speaking people, and also we are online, we are storing all those talks on YouTube, and we want to get to more people, to wider society. So this is why we speak English here, but if you prefer to ask questions in Polish, it's okay, we would understand you, and it's all right. We are hosted by Taumatek, and really thank you very much, Taumatek, for having us here, for giving us this place in the middle of Wrocław. Very nice cooperation. And what more? You can find us on Wrocław.pl, and this is our webpage. There is also a link to Slack, so the Slack invitation, so you can join us there. We are kind of active there. If you ask a question, there would be always someone who would ask it. You can also find organizers there. You can request a talk you want to listen to. You can submit your own talk if you want to tell us something. And today we are starting with talk by Michał. So give him a nice applause.
Hello. Yes, so it turns out I am a speaker today. My name is Michał Chodzikiewicz. I'm an embedded software engineer. And today I would like to tell you that IoT software engineers don't care. And we can't have nice things for whatever reason. But I want nice things, so I am constantly searching for nice things over and over, because
nice things not found.
Something like this, yeah, but I am in constant search for this, because they are that rare in embedded space. Okay, so my recent discovery is Hubris. Hubris is RTOS, just as my previous presentation was about RTIC. This was rather, maybe, let's say, entry-level framework toolchain. I mean, something that you can basically write some nice applications for microcontrollers. But today I want to tackle some maybe more professional topics. However, I will try to keep it as simple as possible. If you will have any questions, if you will not follow something or so, you can interrupt me in the middle. I have no problem with it. Okay, so Hubris, I call it a roly-poly of RTOSs. So what's roly-poly? When I first thought about the title, I searched quickly for something else, and it turned out to be a roly-poly, but there is also other meaning that if you paste to Google Images, you will receive something like this. And this is not what I meant. So maybe there is a joke, because this is a crustacean, so yeah, crustacean, yeah. But yeah, this is not what I meant. I meant a roly-poly toy, which is a different thing. I have one with me. Very creepy one, actually. Okay, so this is a roly-poly. This is very creepy one because it is both Hello Kitty and Babushka. And what this toy does is basically, I don't know if I can show it to you somehow. Maybe I can have, I don't know, some plate or anything, but okay, maybe on my palm. It is basically the toy that stands still. Whatever you do to it, it stands still. So that's a very creepy one, as I said. Let's look inside, maybe. Maybe there are some other parallels. Yeah? That balance themselves like it's Wańka wstańka in Polish, yes. Let's look inside. Let's look inside. I detached the head. All of you Git users might be familiar with it. And I'm not sure if it will be visible, but there is a ball, which we might call the kernel, and some wires, which might be a representation of processes running on the target. No, I just made it up like 5 minutes before the presentation. But anyway, yeah, it might be known for you as a Wańka wstańka. It is like famous toy from the communist era. So how it works is that it has very low center of mass, and if you roll it over, the center of gravity of the toy is elevated, and through the, let's say, path of the least resistance, it naturally balances itself vertically again. Yeah, what does it have to do with RTOSs? It is the best thing at standing straight. So embedded applications need to do given things good to keep performing the task reliably over and over. So yeah, that's kind of similar to standing still as a toy. Okay, so what is Hubris? Hubris is RTOS designed by Oxide Computer Company, very nice company, by the way. They have a lot of cool stuff and podcasts and so on. They developed it for themselves, which has some cons. More on this later. But it is open source, and I am a huge believer that it can be a great fit also for applications that are more similar to what I am used to. Okay. What does it have? It has preemptive multitasking. These screens are just for, I don't know, just to show some assembly because it looks very hard. But basically, how preemptive tasking is executed on the processor level is that the processor has the registers that holds the current state of the process, basically, that is running on them. So if we want to switch between the processes in a way that no process is directly aware of other processes, we just dump all the registers to a struct. We switch the stack pointer to different tasks, perform maybe some minor other things dependent on platform and so on, and load the registers from the different tasks. So each time we switch the context, we just, we are copying and pasting the registers. But we have this in most of RTOSs that are, well, most of RTOSs are preemptive. So FreeRTOS does this, Arctic does this, I think. Everything, basically. So what else does Hubris have that is uncommon? It gives you the memory isolation between the tasks. So each task is separately compiled as separate binary, let's say the ELF file, if you are familiar with it. And it is, and these are all merged together at the end. But this gives you the confidence that there are no common parts between the tasks. So these are isolated not only on a API level, but also physically. If you access memory that is outside of your task, or you access peripheral that is not supposed to be used by your task, it will be killed. And there is a supervisor task. The supervisor task you implement yourself and decide what to do with it. You most likely want to reset it. Because how Hubris is designed is that it makes it very easy to restart the crashing task. So even if there is a memory violation or, I don't know, null pointer dereferencing or something like this, it will just crash on a memory violation rather than on a hard fault or something like this, and you can respawn. Yes, so that's nice, but how is it done? After all, we are on bare metal targets that are quite simple machines. So I thought that there is no memory isolation available. There is no MMU. Basically, there is a rephrase from last presentation. I said here that no MMU, we are dealing with the physical memory. The thing is that we have MPU, which is memory protection unit rather than memory management unit. It does not provide you the virtual address space for the process, but it allows you to define which parts of memory are accessible by running task. So you can basically, this might be a hot take, but I always thought that this MPU in ARMS is kind of a cripple. It cannot be used for any useful thing other than isolating you as a customer from the binary blob with, for example, I don't know, Wi-Fi or Bluetooth stack, which are proprietary. So I thought it's like, yeah, why would I use this? But it turns out it is very useful, and yeah, very shortly how it works in ARM. So we have this MPU type register. It is common to all ARM Cortex-Ms. It tells you whether you have MPU or not, and how many, I think in this section it gives you information how many memory protection regions are available. Most common is 8 or 16. So maybe you ask yourself a question, so 8 tasks is maximum? No, it's not like this. You can change the regions on each context switch. So you have at least 8 regions for each task. So you can isolate, you can allow to access, for example, one peripheral, few places in the memory, and your, let's say the code you're running from Flash and so on, and you still have some other spots to use for something. Yeah, okay. So then we have this MPU control, which basically is used to turn the MPU on and configure some modes of it. Then we have region number register, because there are 2 registers. One is for setting base address, and second is to set settings for given region. So in this register, we just set which of 8 available regions we are applying our settings to. And then if you select one, the next register is base address registers. So you give the address here, and I guess the size of the region, but you need to look it up if you want to go into more details. And then you have this attribute and size register where you, oh yeah, so this region is not about the size, I guess. But anyway, you can set all the attributes here, and well, you're done. Then you can decrease your permissions to the, let's say you can spawn a task, or go to the task in unprivileged mode. Because this part I presented is in privileged mode, so kernel does it. You don't need to do this.
This is similar to MMU, but about paging and that stuff, right?
Yes, this is just about restricting which addresses you can access. Yeah, so we have this ability to constrain every task to only be allowed to do things that are its own. Yeah, for RISC-V, which I think all open source involved embedded developers are very eager to see mass adoption. Also has some kind of mechanisms, but yeah, I don't want to go into many details. I think there are some, this is still in progress somewhat. I mean, some chips has MPU, but I am not sure if this is unified across all the silicon. I guess if it is not yet unified, then we can expect it will never be, because these parts will always exist. But anyway, Hubris is from the beginning intended to be ported to RISC-V. So the company that made it basically uses ARM just because of the availability, but they would prefer RISC-V, I guess. And there is some initial support, but yeah, it is not merged yet, I guess. Okay, so MPU support is nice. It gives us very good opportunities to make our programs safer. But it turns out that support for this exists in Zephyr OS, for example, in SaferTOS. Even FreeRTOS has this ability to constrain the regions. I mean, it exposes the API for you, but it is opt-in, and nobody bother. I mean, at least from my experience, which is very sad. Okay. The thing is that Hubris makes this memory isolation as a contract for basically starting writing on it. So that's the difference. Okay, so it has some message passing. Yeah, strongly typed messages. Basically, you can zero copy share memory using the lease mechanism, which is borrow, like you share it for the further thing that is in separate binary. It is also handled by kernel, so yeah, it's safe. And you can share this as a read-only or read and write. Okay, so I am sorry for the contrast of the projector, but basically, what we have is this is the toml that defines all the memory regions that are in the microcontroller. So yeah, you might have some problems to see it if you are in person here. But here is a flash, starting address of the flash, the size of the flash, and some other things, the RAM, and I don't know, some additional attributes. For example, SRAM1 is used in this example for Ethernet, and it states that it is allowed to do the DMA transactions. Okay, also we have the chip toml, which defines all the peripherals that are in chip. By the way, nice thing that I didn't know is that peripherals are laid out in, let's say, base 2 alignment. So it is easy to apply the MPU because it works on power of 2 regions. So you will not, by mistake, for example, allow the task to use more than it should, because if the peripheral only has, for example, a few registers, then still there is a padding, and no other peripheral is there until the point where you can split it using MPU. So that's not a problem. I was worried that it might be. And each task in the app toml is defined like this. So we have the task name. We set the priority of the task. We say the memory requirements. And yeah, there might be some other things. You can also put into this task some configuration for drivers. Every driver is a user space task, so it is also safe. Yeah. So basically, the interprocess communication looks like this on the low level. So you can send a message to some task. There is this task ID target operation, which indicates which kind of let's say message you want to pass to the task is it. So it's like to map it easily to Rust enums, for example. You have the outgoing buffer, and you have the you.
So like input output, or
Yes. So because this is the message you send to the to other task, and this is where you expect to land to have the response. Because these two are limited to, I think, 255 bytes, so it is being copied between the tasks. If you need to share bigger chunks of memory, it would be inefficient to copy this, so then you use the leases. And on the receiver side, you have the receive open. The big thing about Hubris is that it does not use queues between the tasks. It just uses a single slot. So if you send a message, your task is blocked. This solves a lot of problems in embedded devices because you don't need to care for the queue sizes and overflowing them because they never get overflowed because you only have one element and you block your task.
so the send is synchronous, right? It waits for the
Yes, it is asynchronous. Also, I think I missed it on the slides, but there is also a way for asynchronous communication. This is called, I don't remember honestly, but it basically you subscribe for a bit, and when this bit is set for your task by the other task, I think you receive back your. No, it is not blocking. So you just need to poll for it if the bit is there. And it would be quite painful to use this kind of API to harvest or maintain a big code base. So there are some interface definitions. So this is like the Rust object notation, I guess the format is called, and it is, I think, used by the debug trait. But I'm not sure. But anyway, this is like this way you can describe how the IPC so the message basically this API translates to some higher level API. So for example, here we have SPI, and it basically implements the exchange method with a device index. So I guess this is like the SPI 1, 2, or 3 or so. And the leases, which is source and sink, because SPI is bidirectional bus. So at the same time it receives and transmits. And you define the result type.
Could you go back
Yes.
slides, one slide more?
Yes.
Because the releases in here are shared as shared reference, I see.
Mm-hmm.
At the same time, you can have a mutable list. So that means that it validates it during the runtime, right? That no releases overlap.
Well, your task is locked as soon as you send the message, so there is no problem.
Yeah, that's also covered.
Yes. So yeah, you have this kind of definition, and you generate the stubs from it. So to create a client in your build.rs, you, let's say, just call the generator stuff, and then you include your stub. So basically, you will have the traits in place, and there is. It is a nice read. Basically, Hubris has very nice documentation for the kernel. It is a good read if you are interested in operating systems in general, because it's quite smart. And there is also a lot of documentation scattered around all the repositories. So there are some guides on the conventions and so on. But anyway, so we have this interface that would be more pleasant. And this is for the client side, so for the sender and for the receiver. You have basically something similar, and you need to implement your server trait, which you then just connect to the runtime that dispatches this, inferring this from the interfaces somehow. Okay, so another interesting thing is how the main build artifact looks. So it is a zip file with all the elf file for each task. So your debugger will have information about each task separately. You have your binaries. You have your OpenOCD config inside. You have your app toml config and chip toml config. So you know how the chip was laid out in these abstractions. This will be important in a moment. And you also have, I guess, README from the project, but I'm not sure if. And also a Git commit. So quite a lot of things in here to infer it. So this is very nice because if you want to debug the device that is on the field, you might not be sure which version of the application the processor is running. So you have some hash of the package written in the flash of the MCU, and you also have this in this package. So if they don't match, the dedicated debugger will notice it and refuse you to debug it. So okay. Humility is the debugger for Hubris, and I think this would be better to show this using a demo. That's unfortunate. Yes, I need to quit Manjaro soon because Manjaro has some spurious security issues. For example, they allowed some certificates to time out, and they basically broken the. Yes. So this time I call quit. It is. This time I call quit, and yeah, I will just opt for Arch, which I used for a long time, but I was just too lazy to deal with it. Anyway, okay. I don't know how to do this. Can I increase the size of the? Yes, but no. Okay. Maybe I will just use Alacrity. I mean the terminal. Oh, that's nice. I feel like this meme guy from the weather forecast. I don't know if you recall this, but anyway. Can I? Okay. I believe I can do this. It's Windows Plus in KDE, apparently. Okay. Yeah. So I have a board with a demo. This is demo provided by Oxide. Because I basically wanted to port this to another board and basically replicate my previous demo for RTIC on the Hubris, but it turned out not to be easy. So I just have the board that is supported out of the box, and I just flashed the demo. But anyway, what we have here is the Nucleo board. It's STM32H743, so it's a big beast. It's like 400 megahertz, a lot of flash and RAM and so on, Ethernet and all bells and whistles. So this is basically it. Yeah, from the user perspective, it just blinks 3 LEDs. But the Hubris, being a dedicated debugger for this OS, uses these interfaces I have shown you before. and can do a lot of things in a bit different way than you are used to in debugging embedded devices. Because for what I can do, for example, is yeah. I have this device attached. This is not being debugged right now. So maybe you can see the ST-Link probe is not running. You can see it by the LED that is not blinking. It is not active. And I can write it like no. Haha. Now I am zoomed in and I want to see to the documentation. So that will be fun. Why issues? We just want the README. Okay, so I will show you a few comments. Yeah, so one thing we can certainly do is up table. Okay. Okay. Why is that? Okay, I don't know why. Let's see if different things works. I promise you it worked. So, okay, one thing we can do is we can list the tasks. This is on the running target. We have been not attached. It used a ST-Link to get the knowledge about the state of the system without disrupting it. I mean, it halted the processor, but we did not need to restart to attach the debugger or something like this. So we can see all the tasks that are running in the demo. What is interesting here is that the task ping has the generation number that is very high. And why this is interesting? Because each time the task is crashing, it has this generation number increment. So you can detect if the tasks have been crashing. And the ping is, let's say, the demo task that is crashing on purpose of presenting that it is shown here. You can see state of every task in regards of the syscalls and the state of it. Yeah. By the way, the notification. Oh, the asynchronous way of communicating was called notifications. Da. And this is used, for example, to poll on interrupts. I mean, the Hubris kernel will handle the interrupt, and it will notify you as a task that it happened, so you can do something with it. So you can see that this is waiting for the notification. So it is subscribed for it, and it will be awakened if something will arrive. So you can check if there is a notification. Okay, so basically we see some tasks here, and this is on the live organisms. We can do the trace, I guess. Or maybe let me quickly look at the okay, so very valuable thing that I will not show a lot of it is dump. So we can dump basically the state of the MCU. I mean the memory and so on. And then you can use it to see the stack trace of the offline device, for example. So you can just, let's say, go to your device, download the state, and then examine it when you don't have the access to device. So that's nice. Yeah.
Would you show up if it's not cloud option? Just uses this offline stuff trace.
Yes, I'm not sure if we will have enough time for this, but maybe. Basically, okay, it has. So there was example. I will just shamelessly copy it. Okay, so I will not show this because I don't have oscilloscope or something like this. But for example, you can use the humility to toggle the GPIOs on the running target. So that's very nice. You can also, this I will show you. Yes, you can also query the state of the GPIO. Using this wrapper, so that you generate this code, you can also use it in the debugger. So for example, you can access, yeah, that's interesting. You can access some APIs. Why is, okay. No? Okay, so we have quite a lot of API exposed to the debugger. What we can do with it is, if you can see here, this is a user-led tasks, and it has let on, let off, and let toggle API exposed to the debugger. This is, I guess it is automatically exposed. Sorry, I did not have this much time to explore this. It have only been like, I don't know, few weeks after hours. But okay, let's do this. If we okay, it's -c user. I think I have this in the history. Okay. So what we can do is, these LIDs are blinking in a way that only one of them is on. If we toggle the state of each, the logic is inversed, and we are doing this on the running target, so that's pretty impressive. What we can also do is scan our I2C bus, and it fails. Yeah. So we can scan entire space of I2C, like I2C detect on Linux and so on. Yeah, we can scan what all the registers in the given I2C peripheral contains. And the interesting thing is that I don't know why, but it just works. If right now these addresses are reading 0, and this is because it is dark here. But if I point my light sensor on I2C to the light, it should show us some results. It has some, oh yeah, we can see the tools. I don't know why it works this way. I have not even read through the documentation of the sensor, but I can already see there is an impact.
I2C sensor, or you just plug it into the I2C bus?
I just plugged it to the I2C bus. I have done nothing on the demo. This is unmodified, and I just scan the I2C bus, and I can already somehow prototype.
Submerging it into water and trying to see.
I don't know if, if that's a perfect idea for today's presentation, but yeah. Okay, so basically this is totally different approach than what I am used to. Usually debugging the embedded device is very painful, and this looks like doing some analysis on running target is very easy, and there is a lot you can do. You can, oh yeah, this is like, you can, for example, reset the tasks using the supervisor task. The reference implementation is called Jeff. So basically you can interact in a lot of ways using Humility, and that's very nice. I am very impressed by this. Yeah, how do I zoom out? Okay, that's good. So basically I need to spend a lot more time on Humility because it is such a nice thing. Yeah, it also allows you to run OpenOCT, run GTB through it, providing all the ELF files from this archive. So this is very nice because you get a lot of tools already configured with the debug symbols and so on. This is always very painful for a developer. Yeah, you can read the register states. You can query different buses like QSPI in this example. You can read some arbitrary memory from the device. That's a lot, let's put it this way. So, that's great. And where's the catch? There must be something. So one thing that put me off is that the repository of Hubris is like a monorepo. What it means that you have the app folder, which contains of the demos. So for example, we have the H7 demo. We have this app toml that defines everything. And we have all these demos inside this main repository, which is okay, but then you also have Oxide products in here. So that's not very nice if I want to use this in my project. Also, you have some tasks that might be nice and useful because, for example, there is the network task. But if you look into it, there are a lot of config ifs for different boards. So it is quite stiff if you just want to experiment with it because, yeah, they accommodated a lot of variants of their hardware, and yeah, that's not ideal. The same thing with drivers and so on. Yeah, that's what I mentioned. So the existing tasks are not that reusable. I mean, if you want to add support, yeah. I wanted to port the Hubris to STM32F7 Discovery, and yeah, it kind of sucked because I just wanted to port some tasks that have already been implemented, but yeah, dealing with all the config ifs was off-putting. And I would like to use it for IoT devices because this is what I mainly do. But there is no peak support, which means position-independent code. So if you want to do firmware upgrade in the field using some kind of, let's say, internet connection, for example, you usually don't want to brick your device because you don't have access to it to recover it. So what is a common practice here is to use A-B partitioning. So it is usually like firmware is running in from the A slot. It has some network stack and so on, and the API to perform firmware upgrade. You send the binary to your running firmware. It flashes it to the B partition. Then it resets. The bootloader selects the second partition. It tries to boot, performs some power on self-test and so on to check if the firmware is not harmful, and if it succeeds, it just notifies the bootloader that yes, this firmware is correct. Otherwise, after next reset, the bootloader will, let's say, yank the bad firmware on the B partition and wait for another attempt to firmware upgrade. But this is not possible with position-independent code, because this way all the pointers in the let's say assembly produced by Rust is hardwired to the specific position in flash. So if you want to have 2 images, then it's not that easy. Yeah, that's kind of a deal breaker, but I already mentioned this in the issues. I hope that it is not that hard to implement it, because I guess this only involves some address translation for the for the flash fragments, right? So it should not be that hard. Maybe you need to pass the, I don't know, the arbitrary place where the Hubris image is placed or something like this. But yeah, this should be solvable. Yeah, as I said, this is a microkernel, but it has a mono repository. So that's off-putting if you want to use this Hubris kernel for your project, and this project is constrained in a formal way. So for example, you have medical product like we do have in Taumatek, and you need to prove that each piece of software you have in the scope of your project is safe, or at least to prove that you don't use it. So if you have a lot of stuff from the other company, this is kind of a bummer. Yeah, but after all, I'm a huge believer in this, because honestly, it feels like at some point the industry switched from the very simple microcontrollers like PIC from Microchip or AVRs and so on, and we just gained a bigger memory, more peripherals, higher clock speeds, but we did not change the paradigm. But these CPUs, most of them at least, because there are some ARMs without MPU, but most of ARMs do have this. And why are we not using this if we can make things much safer? Yeah, that's basically it for the presentation. Do you have any questions?
So, how many tasks would like typical device have? I don't know the definition of typical device.
Yeah.
So, because this feels like cool Rust project, but all you said to me, as a non-embedded programmer, even though I understand most of the stuff, because I do deal with ADR in my free time, it felt kind of abstract. So, asking for instance to ground myself in how many tasks, because this is the first thing that comes to my mind.
Yeah, okay.
How would you, I don't know, there is some device, for instance, that
Yeah.
you had to do in the past, that you've done in the past. I think I know how to phrase this question.
Okay.
If there was some device you've done in the past, how would you, for instance, structure the project? So, divide it into tasks, or you had some device that you would be able to, quickly describe to us what this device done, and
Okay.
provide some, details how the code was structurized, for instance, according to tasks, or if it...
But you mean not in Hubris, but in my past?
Yes, because you haven't had a chance to use Hubris apart from the,
Yes, indeed. But in, let's say, typical FreeRTOS application, for example, usually it is like you can count your tasks with your fingers and toes. Let's put it this way. But it depends on the granularity. But if you don't have a benefit of isolation, then you just pay for additional stack space and so on. So you tend not to bloat your software to have a lot of tasks, which, yeah, Hubris might be a bit wasteful here, because if you just want to implement each driver is a separate task, has a separate stack and is isolated, then it will consume a bit more memory than if it would be all unified and link time optimized. But if you do the project that is safety critical, you are willing to get a bigger MCU, for example, and accommodate the overhead. If you, let's say, the big thing is to mitigate the risk. So you do the risk assessment. You try to identify all the risks that your product, for example, for a medical device, you need to identify all the ways that your device could possibly, for example, harm a person, and you need to mitigate with, you know, all your goodwill, all the potential risks, the best you can. So if you have a memory isolation that gives you the ability to restart the crashed driver instead of resetting the entire device, it might be a life changer for all the people who work on this risk analysis, for example. Yeah, but this might be a bit wasteful, but I think it is still fine regarding the benefits. I will just elaborate a little bit. So, for example, for a typical IoT application in the health tech, let's say it is like you have, for example, something wearable that, I don't know, measures some properties of your life being. So, for example, like, I don't know, maybe a blood pressure or skin temperature or, I don't know, whatever, blood oxidation and so on. Yeah, this is basically one of the use cases that are in Taumatic. But anyway, so this is in this application, this is used to take care of the elder patient. So if you will lose the communication with this device, maybe you will miss that something is happening with the patient. So having the device not to reset is very valuable. Yeah, you basically, yeah, this is basically acquisiting the data from all the sensors, process it somehow, and send it to, let's say, the cloud. And yeah, so if a single sensor driver will crash, then maybe it is not worth to reset the entire device and flush all the data you had, because there was some arbitrary error and you cannot infer what is incorrect. So you just need to start from scratch the application.
So the worst case would be like a Meetup, right? You haven't had separate tasks, and there was something early phase, then it was task.
Yes.
The same thing fails.
Yeah, and you can also, using this supervisor task, this is also a big topic. You can, for example, also ship the statistics on how the device performs and partially debug it, publishing all the statistics to the cloud, and this would be very helpful sometimes. Yeah. So, sorry, you had a question.
What does this company behind Igris is doing actually?
Yeah, that's a good question, because it relates a bit to the lack of PIC. So position independent code support, because what they do is rack scale servers, and the Hubris is used there to orchestrate all the miscellaneous stuff that is being done in this big hardware that has a lot of, let's say, you know, the x86 CPUs and so on. So it's like a big chunk of server. And there are a lot of microcontrollers that, for example, I don't know, orchestrate the power supplies, maybe initiate some chips, for example, to upload the byte streams to the FPGAs over there. I don't know, maybe in a Ethernet switch or something like this. So there is a lot of things to be done, not by this fully blown x86 processors running some big OSs like Linux or something else, but you also have a lot of firmware there, because you need to, I don't know, maybe yeah, I'm not that much familiar with what exactly do they program, but for sure they have their own Ethernet switch, which is quite advanced and so on. So all the firmware is, I mean, or at least most of it is using Hubris to do these tasks. But this use case is kind of specific because they always have physical access to all the MCUs. So they don't need to run over-the-air upgrades. They just can, most likely they have UARTs attached to, I don't know, some supervisor chip that can always perform updates for every device that is in the rack. So why would they need this position-independent code, for example? Yeah, that's not beneficial for them. And as far as I can see, they are kind of in a hurry to ship their first product. So yeah, that's also a thing. Any more questions?
One is how resource handling is used.
Can you?
How many resources does use itself?
Uh,
Or like how much RAM or
okay, so the kernel that's a good question. In the demo application, it is described in this TOML, I hope. So kernel is using. Oh yeah, sorry. So it takes 22 kilo of flash, and 4 kilo of RAM. But I think, yeah, this might be it. But for example, the supervisor tasks take 8 kilo of flash and 2 kilo of RAM. There are some smaller and bigger tasks, but yeah.
So if you wanted to disable some of those features, and still keep like the core functionality of task switching and stuff,
Yeah,
to disable like Jiffy or some of those.
I think you can do this, but I have not experimented with it so far. How do I? Yeah. Let me see another demo, because I think for STM-F4 there was a very small demo, so maybe no, it's like, yeah, okay, so the footprint of the kernel is like 20 kilo of flash, so it's a bit, but yeah.
And do you know how it compares to like top or ever?
Can you say louder the other projects?
Do you know how it compares to like top or Arctic?
So Arctic I think is much more lightweight, but it is basically like a framework that only does some nicer abstraction around the specific peripheral in ARM, so it is expected. This one gives you, let's say, much more. It orchestrates all this memory isolation and so on.
It's like the operating system, right?
Yes, it is. The TOC OS, I think, by the way, Oxide, I think, used TOC OS, but decided that it is not a good fit for them, mainly because, as far as I understand, they had a problem with the possibility to upgrade, to, let's say, to upload new tasks and upgrade them as a separate processes. So it was not their use case, and moreover, it was like additional attack surface for them. So why do this? So after some discussions, I guess they decided that they need to spin their own kernel that will be more stiff, more static. So you cannot create the tasks on the fly. Everything is defined in the TOML prior to building.
The second question is like what other hardware like operating systems have like upgrading firmware?
Upgrading firmware. Usually this is application specific. I mean, some kernels I think have some, like Zephyr, I am not sure, but I think it has dedicated firmware over the air facility. For sure, the ESP IDF, which is, let's say, the tool chain and for developing ESP32 chips, it has the firmware over the air bundled, and it works quite nice. And I don't know if what I'm used to is that you write it from scratch or use some ready-made components, but you need to bring it into the project, and it is not. So the thing is also that the communication stack you need for the upgrade is usually large, so you don't want it to have it in the kernel or a bootloader or something like this. So we just spin a task that is able to fetch the new firmware package and put it on the flash. Mm-hmm.
Then meaning that when a task runs out of those resources, it is automatically killed.
Yes. Yes, and also just as in the flip link I mentioned in the previous presentation, it also has stack on the other side. So if stack will grow out of the given region, it will be killed. So you want, because usually there is a static data above the stack, so you overwrite your static data, but and you don't know about it. But in this paradigm, you will be killed. Yeah. So, any other questions? Mm-hmm.
Information of memory, then jump to it, and because it's position independent, we just have it to work, right?
Yes.
So why does position independent code makes it harder to do OTA updates in this case?
No, there is no support for position independent code in Hubris. So this is a problem because all the addresses are fixed. So the limitation is basically that it applies. Okay, we can quickly find this piece of code because it's quite interesting and straightforward for a kernel code. Yeah. So there is this apply. Yeah. I will increase the size of the font. No worries. Yes, I will do this soon, but I just want to. Am I in the? No. Yeah, that's the wrong file. This is why I wanted to find it first. Okay, so there is this apply memory protection, which is run on each context switch, and yeah, it is implemented very simply. So for given task, you have this region table, and you just fill it out. So if we wanted to add the position independent code, you would need to somehow detect that this is a flash part and translate the addresses. But yeah, I don't feel like this is impossible. No. They don't have support for it. But I am not sure why, because this is even documented that they don't support it. I mean, if I git grep, there are some mentions somewhere. So this was deliberate, and I hope that, yeah, that it will be possible, because I don't see why not. Okay, so I guess that's all from my side. Thank you very much. I hope you enjoyed it. So now Now we will have like 10 minutes of a break. So, yeah. And then we will come back with the second presentation.
your link is hashed.
Hashed.
Okay.
How did I name it? Wrocław, I guess. Somewhere. Okay. Okay, it's okay. Okay, hi. It's me again. And my name is Bartek Kuras. And today I'm not only Wrocław organizer, I'm here on behalf of Confio, which is my current client. And this whole presentation would be like 2 days of my work in Confio, compressed into half an hour. So you can treat it either as an ad or maybe as a warning before coming to us, but this is how do we work. I would do some live coding, live debugging, no presentation today. And let maybe create some context for what happened and why did I struggle for like 2 days not committing a single line of code. First question is, are you aware about Serde? Who is aware about Serde? Maybe raise hand. Okay, I expected that. I guess you are not aware about Cosmosm. Or maybe is there anyone? Jan is, but he's...
CosmosDB.
Sorry?
CosmosDB.
Cosmos is an implementation of Cosmos. And Cosmos is like blockchain standard. So
WASM.
yeah, Cosmos, and then WASM like you know WASM. WebAssembly, exactly. So, what is the problem? Let's create some smart contract using Cosmos, using our framework, like very simple thing, to show you how it is structured, and then we would go directly into the problem I had. So let's create a project named, I don't know, third problem, because it was a third problem. Cargo new, and I need probably a folder here. Okay, sure. I would go to the project. I would add some dependencies. It would be Cosmosm stud, so our standard library, and cargo add, and our main actor here, Serde. And I need a derive. If you don't know this cargo add tool, it is already in standard cargo. You do not need to install anything to use it. It just modifies your cargo tom, so it's easier to manage your dependencies here. Okay, so just to create the contract quickly, we need to set up some stuff. We need to, you see, this is how long it takes to run NeoVim on my machine. So. Do not use this machine. What I need to do, I need to do some magic in my cargo tom, because our smart contracts are basically dynamic libraries compiling to the WASM. So our virtual machine can just load the dynamic library and execute it, but I would also add a lib. I'm not sure I need today, but it doesn't matter. Okay, and then I need to go to sources. And I need to make some implementations. And here, I would have smart contracts would be just a bunch of entry points which are executed when we are executing some message on blockchain. If you don't know anything about blockchain, it's okay. This talk is not about blockchain. The idea is that smart contract is a single application or a single state in the blockchain database, and you can perform some actions on that contract, right? So what I would do, I would create some messages here. So let's create some init message. So this is the first message sent to contract when it's created. It would be empty. Okay, I don't know what did I do, but let's create a simple message, public structure init message, and I need couple derives. So serialize, I guess debug, clone. I think I'm good with that. I need to import those. Nice. And I need another message, and this would be way more important one, which is exec message, and this is enum. For now it's empty, because I am just preparing like structure here. So what I need here, I need my instantiate function. Instantiate. So this is like my contract constructor, the first entry point, which is called when the contract is was created. It's like I need a bunch of arguments, and it doesn't matter too much. Info. And I don't want to have any message here. No, I want my message to be init message. And here I return some stuff. Yeah. I was curious why it doesn't work, and but I don't care because I can just now, import it.
How do you import this object?
Okay, so I use Rust Analyzer plugin here with what's called, I don't know, remember the compilation tool for NeoVim. It's it's not COC. It's something new for NeoVim directly, and there is this thing which is called code actions on this plugin, and this is supported by Rust Analyzer basically. So those code actions are delivered to this plugin by Rust Analyzer, LSP API, and then I just perform like code action, and I can do like, if I would do it slowly, you would have some hints here. I can do C for code, then I have A for actions, and those are actions I can execute on my line here, which I can do some stuff.
Like involved in IntelliJ.
Kind of. I just do it like quickly because I actually remember what happens. Okay, and here to make it actually entry point, I need to use the entry point thing here. And now I would copy this whole thing. I would call it execute. Okay, and this is the entry point, which is called every time I would like to perform some action on the contract. I would not implement anything here. I just want it to be a proper contract, so it compiles. For reasons I would explain in a second. So, okay, I have my smart contract. I need to compile it, and I would do one more thing. Cargo config. I would add an alias for me, which is wasm being. So this what I do right now. I create alias for cargo, so I would not need to call this command all the time. And it is because I need to use not standard target for my binary, which is wasm32. Okay, so I need to create a folder. Nice. Right now, it's the contract is proper smart contract, minimal proper smart contract. I want to build it using cargo wasm. Okay, now I would use small tool. I would find my my wasm files generated, and I would use code CW check contract, which checks if smart contract I created is a proper working smart contract I can upload to the blockchain, because not every code produces smart contract I can upload, because there may be many reasons why the contract is not a valid one. So this one is valid. You see that contract passed. And let's go into my smart contract. So you can see that my execute message is an enum, and this is how we typically do this, because in the enum we have different executions or different actions we can perform on the contract, and then we just have a match in my entry point which dispatches to some handlers, right? So this is intuitive way to do that. So we would have like a message foo with some thing here, right, like this, and some bar with some other thing here, with nothings. And I would actually use those curly braces here so it serializes to JSON better. So this is implementation thing. So I can add some execution messages variant, and right now it should still pass, right? So red liberty it quickly, like check the contract, everything is fine. And now there's a problem. So I had an issue that I wanted to have like smart contract which implements like two different interfaces. Like I wanted to have a contract which reacts to a bunch of messages which are typical for one contract, and a bunch of the other messages which are typical for another contract. So this is very much like interface implementation. But so, as you can see, my interfacing here is solved by, taking messages, like taking enum and deserializing enum. So how do I do that? Does anyone have an idea? How can I react to two different sets of messages in one contract like this?
So just the server activity you can call enum and target.
Exactly. So let's try it. I would have two messages here. Sorry?
He knows the answer already.
Yeah, he knows it. Yeah, because yeah. I mean, because he writes that he doesn't know Cosmos. Cosmos is open source. Everything we do is open source. So he just went to our code base, right? And he knows everything. So let's create a structure A, which is my one set of messages, and another structure B, which is another set of messages, right? And I would have here A, right? It's J. But I don't want to like decorate it anyhow by Serda. What I want to do is to make them transparent completely, right? To deserialize directly to either A or B. Obviously, here it doesn't make sense because those are deserializing to very much the same thing. But in general, I assume those messages are very much distinct. So it deserializes properly either to one or to second variant. But here this is just to show that it doesn't work. Yeah, so I want to use this third untagged thing. And what I want to do is obviously to build this and be happy that I solved my problem, right? And then I go home. I mean, this is a moment when you take leave. So let's read the answer, the message here. It is like, I have a compile error, which is that could not compile, WebAssembly translation, blah, 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 float operator detected, F30 to load. There's a problem. Floating point operations has this characteristic that they are not very much deterministic. I mean, they may be sometimes apparently calculated differently because you have another, CPU on your machine, or maybe something is implemented directly. I was actually not aware about that. I know that there were problems with float points. I mean, we are all aware of problems, but it turns out that they are actually not always deterministic. And on the blockchain, we cannot have undeterministic things because it is the thing that if one node calculates the hash and the block, any other node has to be able to exactly verify that the node is exactly calculated properly. Everything has to be very deterministic. And because of that, in this wasn't binary generated by compiler, we cannot have any floating point operations, right? And that's a problem here, because it is generated by SAD. How many floating points do you see in this code? I mean, not too much, right? Not too many. Yeah, there is a problem, right? So where is the difference? That's the question. That was my first question. Where's the difference? The difference is that I changed implementation of the serialized struct, apparently, right? And serialized, but I mean, I checked both, and spoiler alert, deserialized is a problem, right? So what I do in this case, I just expand the macro. And now we are looking into the internals. Nice, right? So what does Serde do? set is first trying to deserialize some content, like deserialize the content, right? Something, deserialize. Okay, so this deserializer is my deserializer, which is here. So it tries to deserialize my whole message to some arbitrary content, whatever is it, and then it tries to deserialize it to my variance, y by 1. So, I mean, this is reasonable, right? How you would approach this. And at the end, there is that the data did not match any variant, right? So, very reasonable approach, but there is a problem that this approach makes compiler to create a floating point error. And I spent like a day or two on that to figure out what happened. So let's think about how is it even implemented under the hood to deserialize to content. What is the content? This is the thing. Content is any value you can deserialize into. It is like intermediate representation of your data, because you need to be able to like later forward it. Because how Stata works is it deserializes your data like on the flow. It doesn't keep those data deserialized up to some point. And if you need some like intermediate representation, so you can then try to deserialize it further, you need to keep it somewhere, and this is why the content is. So where would you look for a problem? In the content, probably. Because apparently this content thing is not generated without this untagged. So what did I do here at this point? I sweared. I mean, I sweared much. But then I was looking for some tooling, and there is this thing that your WASM binaries could be actually decompiled to what is called the VAT representation. And VAT is readable WASM format. And what I did, I just found my binary, which is like, I guess, target, WASM whatever, and then release and set the problem. WASM. I made it right to contract.what. And now let's go to contract.what. Very nice thing. So this is how, and believe me or not, you can read it. If you spend some time, it is possible to go through this 77,000 lines of code. Okay. So I actually had to analyze this file, but take it slowly. What was the problem which occurred was like F30 to load. So I studied for a bit how this VAT format is structured and so on, and I am looking for F32.load. This is the operation which was generated and it caused problems. So what I do, I just go up and I'm praying that this is reasonable and that I would find some symbol, and the symbol tell me something. So you see the problem, right? So this is my symbol, and I had to do something with that. Hopefully, I can do something with that. I can. I would create my new file, and I would call it names. I mean, when I was working with that, I was using many names, but just put one thing here. And now there is a tool which I forget the name, but I wrote it down because I was sure I would forget the name. It is called Rust lift. Okay. So what I would do, I would call the Rust lift or lift. No, let's quickly find it. Cargo. I did it today. I promise you. I just Rust filter, not lift. Rust filter, like filter, because it's basically created for filtering stuff from debugger. So I would just pass here my names file, and what I get, it is demangled name of my function, which is helpful because right now I know that the problem came from the content. This is where the F32 operation is generated in the function unexpected. So let's go to the function unexpected of the content. I already checked out the setter here. So it's cloned here. I should have it. Let's go. It is private D content unexpected. Oh, nice. Private D. Now let's go for content. Struct content, I guess. Enum content. You may be right. Yeah, this is the thing. It has some stuff here. It has some stuff here, right? And unexpected. And what unexpected does is like it moves some stuff here. Basically what it does, and matches what there is in the content, and then it just converts it to an error. So, nice. Okay. Right now I was not sure what to do with that, so my first attempt was, let's try not to call this function anymore. Do something so this function is not called anymore. So what I did, there is another tool which I obviously forgot the name of, but hopefully I created this tools file. It's Twiggy. So what is Twiggy? Let's go to my contract. I would call Twiggy paths right now to show you something. I need to pass the contract, which is, I guess it should be in my history. Yeah, there is. It is, but no, not that much. Sorry. Okay, I call my contract. It's had a problem this time. Lost file. No release. Sad. That was some type of problem. So what it does, it creates me this call stack, which just not even call stack. This is the graph, which represent how my functions call each other. So it looks pretty useful. So maybe let's cut my names, because it should be useful to try to, if you would look at the argument path, you can go and pass the function name you are interested in. So let's paste the function name I'm interested in. Except it didn't do a good job pasting the $sign. Okay, not very helpful. My function is never called. Yeah, it's like, so I struggled, but the problem is that if I would put a demanger function here, it wouldn't work too, because it has its own format of how functions are named. So what you can do, you can grep for your, what was the function name? It was unexpected. You can grep for that. And now I have my function name. So it is just formatted differently. Now I can pass it. Yeah, and it didn't have to match, because now I was just sure that it is called in some set deserialize directly, someone deserialize. And now I spent like too much time, and I will tell you what was the problem. The problem was optimizer, because this unexpected function is called in almost every set things under the hood. The problem is that in most cases, it exactly knew what structure it deserialized to. And it exactly knew what can be under the hood. And it was all okay. And also the problem was that when it had this additional object in the intermediate, which was the content object, it could happen that my structure was, the structure I got from the user, my JSON, was not a proper message. And then when it deserializes, it would just copy this floating point to another error. The problem was actually changing the type of an error and copying the floating point under the hood, because this using F64 load. The funny thing is, it would be implemented with memcpy, it would work, because it's just memory copying. But yeah, but you know, okay, we have a problem, you know, so it's a root cause. What is the solution? We can patch Serda, right? So let's go, patch Serda. That would not be this difficult, because what I need to do is probably just remove those 2 files, right? And then there would be some problems, because I need to return some error, but I wouldn't even do that. I would go to my content, right here, right, nice. I would remove them. No floating points in my Cosmos. I would now need to do a quick thing. Cargo, go to set. I need to quickly remove all uses of this, but it would be not too much places. 62, right? I mean, actually, not too much uses. All uses are like this. I thought so. It would take like. Let's go to diagnostics list. I guess another one is here. We never visit this one. In this case, we can just do OK. No OK. We can just do error. And how this works is F, I think, custom. Yeah.
So show them maybe just unreachable, but you cannot panic in a contract.
Panicking in the contract is very bad idea. You can do that, but the error message which you get is not very helpful. I mean, right now we could even do unreachable. Right now we are doing proof of concept. We are not implementing it. You can just return some error. It doesn't matter. But you know, I would not panic because of how stack trace looks at the end. But yeah, it would be a way. Okay, and last 2 guys. I need to build my set. I need to make sure it compiles. Oh, this happens when my NeoVim takes ownership of Rust cache. Okay, doesn't matter, there are some warnings. For now, it's proof of concept. So what I need to do right now is to use my new Serda in my smart contract. And I mean, come on, it's easy, right? And who already knows what would be a problem? Any ideas? So, no, it would be too easy if it would be enough.
The right macro will be picking some other.
Yeah. So our dependencies here is like let's do the path, and my path is, I guess, Serda, and I think this is a path. Yeah, and I was really hoping it would work, but let's build my contract, because no. I was already opening my champagne actually at this point. Yeah. I was so naive. Yeah, something in my Cosmos STD is claiming that my messages are not just ignore. Oh, still. Okay, so something was like, you are not implementing deserialize, but I am implementing it. The problem is from another crate. But there is a solution for that. So we are one step closer. I don't know if you know. Okay, you can also, paste something you just deleted in NeoVim, but O should not be right next to P. But you can do this like patch.crates.io. I think this is the syntax for that. And here I'm saying that anytime you occur the dependency, you just substitute it with path being my path. right? So this is the purpose of this is actually to proof of concept thing and to work on patches for some things locally, and then you can just push this when they work. So that has to work, right? Okay, let's pray. Yeah, this was the end of my first day. I just closed my computer, and I was considering a very, very long leave. There are other crates which are using SERDA, like very much internals of this, and it tries to use my my F64 variant of content I just removed. Yeah, the funny thing, I was reading this message. What happens to me? So now I'm wrapping up right now because I found this. I mean, my solution at this point was I actually patched the SEMRS, and I patched 5 libraries. So my smart contract compiled, and it compiled and it worked. There is a problem. When you are a small company, hiring, I don't know, 5 Rust developers, maybe, not even, I think. And this was actually for Sylvia Crate, for my own open source library I figured out. And I was the only guy who was working on that. You don't want to be maintainer of 5 forks of big crates. I mean, you don't want to do that. But it turns out that right now I am maintainer of fork of the single crate, but it's not 5 anymore.
Because you can just leave the inner variants, but just remove them from the message, right?
What I did, I created the SERDA CW value crate, which is a fork of SERDA value crate. And what is SERDA value? It is just a content. This content thing, just extracted. So I created this this whole SERDA CW value, and what I did there, I just removed all those floating point stuff. And what I did in my okay, what I did here, I just do argo add SERDA CW value. So I use the thing. In my contract, what I do, I have this untagged, and so I need to remove this patch because with this, let my LSP not contract that. You don't want to look into that, but you want to remove that. Nice. And what you do here, you just implement your deserialize trait manually. And the implementation is easy. You just do let value, I guess, is value from this deserialize. You need to pass the serialize, you just pass it, I guess like this, and you do if let OK message is value clone deserialize into, like this. Then you do you just return OK OK message A. Then you copy this. And you use message B. Obviously, it's from exec message. Exec message.
Also get A inside, but should be MSG.
Yeah. It's and yeah, message, and here message is the value deserialized into. It listens the result, right? And if it's okay, actually you should also probably not just ignore an error. You should probably collect those errors, and in case if it is not working, then you should somehow report this. But it is proof of concept. We are not doing this here. You just do the error and then custom, I guess. Right. So you just tell it was an error in this case. And this is how I needed to serialize needs the. Obviously, I do not need to. I cannot derive that, and I don't remember exactly in case of error. Okay, you just need to return an error. Let's not go into that because this is detail. I don't want to clone in Rust. One thing to improve, and it's not yet done, I would like have another wrapper which is like value ref, which allows me to deserialize from it without giving out the ownership, so I can save some clones. But I mean, yeah, it would be done somewhere in the future.
Without comma, I guess, after we are implemented.
Yeah, so I do not need to clone it every time, and maybe. Sorry?
Oh, sorry, because could you go back to the code?
Yeah, obviously I can.
I was so sure that after this unimplemented, you put semicolon,
Yeah.
so then it feels like you don't return any value, so you return unit.
Yeah. I mean, did it compile? It's fine. It compiled. I don't know how it compiled with this. It compiled because it figured out that code after that is unreachable. So because of that, it's all okay. But
It's marked removes it.
yeah, it should not be there. Let's check contract because I was claiming it would work like couple number of times. There's no reason to trust me here. Check what is wrong here. Check contract. Okay. It works, and this is how I solved the problem by, taking out some internals from Serda and then using it only for this deserialization. But this is not the end. I mean, this is mostly the end of what I wanted to tell you. But there's a problem. There's a thing. How I even get to that? So I find that this way of implementing smart contracts being like, just entry points, like bind functions and then taking like message internally, I mean, it's not the mostly clean way. It is not very semantical. It's just, bunch of procedural code. So what I like figured out is that we can define our entry points like a traits. And our smart contract as a structure, so the structure would implement traits, and those traits would be just functions. And I would generate all of those JSON and all those stuff like on the fly. And this is how the Sylvia framework burn. So I actually can show this code because it is open source. And this is nice thing about working in Confio, that if you have a good idea about your open source, you will be able to work on that in your working hours. And now I can just create task for that. And this is Jan here. Jan is actually working on developing the Sylvia framework right now because I am kind of busy. I want to show you how you can create smart contracts using Sylvia framework. So it's not the best idea. I know what happened. Let me git main and let me pull the newest version because, as I said, I do not use my laptop for work, so it's not the most recent version of that.
Why is it main, not master?
Okay, do not go into that. I mean, it's just when you are like company and you are trying to go into the market and you try to get your clients, then it's better to be very much compliant to the society, because we doesn't care if it's master or main. We actually prefer master because it's like it was always master, but because we are used by clients, we just want to, we are not social justice warriors. We just don't want to have active. If you are like you are a person, then you are allowed to fight them. But as a company, we want to be natural, and right now main is better way to do that. So let's go to contract, and as you can see, our smart contract is some structure with some state in that. This map is our internal way of telling that there is a map of addresses to empty, so it's basically a set of addresses here. And you have like these traits. If you would go to implementation of the state is just a trait. I know there's this creepy warning. There's pull request, which is cleaning this warning up. So you just create your interfaces. So those are how you can call your contracts, putting all the arguments here. And there is this interface macro, which when you expand it, it creates for you. The trait, which is just copying it into that, it generates the messages for you. It generates some boilerplate functions for you, and it generates this very nice. Okay, no, not here. This very nice deserialized, but not here, because here are just interfaces for our contract, and here when we implement those interfaces, so our contract can add member here, it can find member, it can even do some stuff which are not in the interfaces. It can remove member, which is not a part of any interfaces, right? You just implement that, and there is this another contract procedural macro, and this guy is actually implementing this serialized thing here. And all things work. So you do not need to you don't need to even think how your contract is generating all those messages. It just has some actions like in gRPC, let's say, and it just handles them. And it can it's not yet implemented, but it would generate JSON schemas for your messages. So your external tools can just take the schema and know how to call the contract and how to work with that. And this is what I do right now with Jan in Confio, so making life easier. And yeah, this is what I wanted to show you, this nice struggle with SERDE and the problem that we cannot use floating point numbers in our system. The Sigma framework, if someone is curious, will be usable pretty soon. We are releasing like 0.2 version, like I hope like maybe next month or somewhere soon. I don't do any promises, but if someone is interested in creating smart contracts for this platform, or maybe you're just curious, you can check it out, maybe even participate. This is all. I have any questions?
Yeah.
Sure.
Pretty great presentation. But
Thank you.
Is like you wanted to implement one smart contract with two different messages. Why don't you just do and make two separate smart contracts?
Okay, so there is a thing. The first time I faced the problem I am trying to solve is the CW20 contract. Oh, okay, CW20. What is it? Is a virtual token, and this is a contract which it is okay. Let's just find it because it's also open source, so I can just show it. It's here probably. I hope it is semi updated version. Doesn't matter. If you look into the state of the contract, it has some not important stuff like token info, marketing info. Those are crap. And this is what is the CW20. This is the map which maps address to number of tokens he owns. Great database with this information. Who has this token? And there is this thing that CW20 has this notion of transferring money. So you can tell, if you can go into message to see the execution message here. Okay, it's like in external crate. Okay, so this is how the execution message for this works. So you can send the money, transfer the money. This is the transfer message, very simple. And you tell that you want your money or tokens to be transferred to the given address, which is string, it's address. And this is how many tokens you want to send. Very simple thing. But there is also this notion of send. And how the send works. Send tells that send those tokens to another contract, and you have amount of those tokens, but doing so, execute the message on this remote contract. Right? And those tokens would be actually sent only if the message would succeed. Because if in our system, when the message is failed, then we just clean up the transaction, right? Because this is a very transactional system. And there's this thing that this message we are sending here, we would wrap it into the message receive. I mean, there is the interface your contract has to fulfill to be able to receive the CW20 tokens. You need to implement the message. So we had a bunch of contracts which were able to receive the CW20 message. And what we did was just add this another enum variant there. But you need to know what variant to add, and you need to exactly remember that. And the problem is that compiler would not prevent you doing a mistake. If you do the typo there, you would figure it out in your integration test, but compiler doesn't help you keeping your interface together. So I wanted to make smart contracts like having their interfaces defined in the way which is very semantical. So compiler helps me to properly use those. And we would generate more. We would generate like utilities to call external contracts and so on, like calling the functions. Because right now it's not so simple, but this is because this Cosmos framework is not high-level thing. It is low-level implementation on some standard, and now I am building high-level framework to build on that, right? But the idea was not that I want some huge contract with like hundreds of messages, but I wanted contract which does its own thing and is also able to receive CW20 tokens, and maybe is able to react to another how it's called callbacks from some contracts, and you react to callbacks by implementing some particular messages. So this is the answer for your question. And the other question.
Have you maybe also tried enabling LTO?
Sorry?
Have you maybe also tried enabling LTO, which is like
LTO? Like that, we are not enabling LTO because we don't exactly need it. It takes time, and LTO is not good enough for us. Because after LTO, contracts are still too big to upload them to chain. And what we are doing, we are calling the WASM optimizer on our binary afterwards. And it turns out that it doesn't matter if you did LTO on your binary. The Rust optimizer would, take the same time to compile it. And so,
I meant for the floating point problem, because it feels like maybe the LTO could...
I did it. It didn't help. It didn't help, basically. I know what you mean. Actually, if it would help, it would not be a problem, because actually before I was doing all this stuff, I was calling the Rust optimizer on that, the WASM optimizer, which is doing LTO first as its first phase, and it just didn't. There is this problem that it just moves. I mean, I didn't dig this deep. How? Because I know that I could, but I just didn't want to spend this much time, because this is very low-level stuff. Why Rust didn't figure out that it could optimize out this very move? because this is just move of floating point. And if you would go into this binary, I was looking for every operation of floating points, and there was only loads. So only copying those in memory, nothing was actually called. Right? But just to be safe, our WASM platform doesn't support any floating point operations. We just, even stripped the VM from executing them. So it's just very deterministic. So it's safe in terms of tokens and token transfers and so on. Yeah, but LTO didn't help. Good. I tried it. Yeah. Okay. Any other questions?
Yeah, could you ask, for example, certain maintainers to add feature flag, floating point or something like this, or would it be so hard and tiresome to implement for so little benefit that they would just say no?
I mean, I will be honest with you. I did not try, but I think the use case is so niche. And it is actually, I mean,
It is not.
okay, I may try. Actually, good point. I didn't try because you are at the point, I mean, Serder is kind of a big library, and I would not expect fix tomorrow. And I was at the point, I just needed it. So I just solved the problem, but I actually could try because, but the problem is, what is my problem here? You could do that, but then you need to ask, for example, schema.res and all those other library maintainers to actually take this feature flag into account and add their own feature flag, and it is like kind of endless battle. And my problem is only on this WASM. By the way, why? If you are curious why this CosmWASM thing was schema.res thing was not a problem, and there is some moving of those values, it is because the whole schema thing is not compiled into binary. Like, it is compiled in, but it is that code, and this is just stripped by the compiled. It is used only in our examples, which are generating schema for you. So that's why does not generate a problem in this runtime.
But there might be very similar constraint in some embedded devices that you don't want to use floating point unit, and you want to use Serder.
I mean, by the way, Serder is very light Irish. I mean, it's very quick, and so I think it actually fits embedded in many cases.
It does.
Yeah. So I can actually create an issue. I promise you, I will do this. I will not do this today, that is for sure. But I will do that just so I can tell you that I did. But there is this problem I mentioned, that it's not only Serder, because you've seen I updated Cert. I patched my body to use another version of Cert, and then schema.res is just using this, and you would need to reach all maintainers of all your crates which are using Cert internals to also take it into account. And I mean, maybe, but I am not a believer in this case. I mean, I just create my fork, which is Serder's.
Does downstream crates need to obey for this feature? I mean, they could just.
But if you would use this crate in your embedded code, and even if you don't care by floating point, as you've seen, because you removed the floating point from the structure, and they was matching on the structure, if it uses set internal, it just doesn't compile it. So they need to take it into account if you would like to want. And
So we challenge you for a battle.
I mean, I will not go into a battle, but I can poke them a bit. I mean, I can poke them, but I am not, I mean, I have 3 kids. Man, sorry. I have battle every day. I have battle every day. I don't need. I mean, once you would grow up, so yeah, you have another task to do. Yeah. He's not my kid, but I am creating tasks for him, so sometimes. Yeah.
So to be sure, the issue came because you wanted to replace this binary with some specific enum, right? Or I misunderstood you.
So sorry, could you repeat?
Because I understood that the issue originally came because you wanted to replace this particular binary with the actual enum.
Not this particular. No. I mean, when I was working on Sylvia, I didn't start with the CW20 contract because CW20 contract is very simple in terms of how it works ideologically, but I mean, it's a bunch of code. And I started with something very, very simple, which is YTX contract and then the group contract. So issue came with actually the CW4 group contract, which is just group management. But the CW20 contract is how the idea born. Like it's the root of the idea of Sylvia framework. Yeah. But this is the ultimate idea to substitute, like, not even this message, but I'm not sure if I would able to quickly find this. Let's check this one message. Okay, in this contract, which is CW20 ACS20, which is very complicated thing. It's very complicated. It implements inter-blockchain communication. But you have this received here. And this just means that this contract can react to this CW20 receive message, right? And I wanted to actually substitute this execute message with execute message, you know, having either those three things which are this contract specific or this, and I wanted to make this transparent, right? Maybe not in this, I mean, this particular contract for sure in the future, because this is like bleeding edge thing right now, ICS, but yeah, this is the idea. Because, you know.
I have one more.
Sure.
You said that the error occurred because you used untagged attributes.
Yeah.
Have you tried not using it?
Yeah, obviously. Obviously, first of all, I tried to figure out how to implement the deserialize function for it without untagged, right? This is the first. So I used set the value for that. So I mimicked how this is generated.
Okay, but you don't have to use value, I think.
So
Try to deserialize into different types and see.
there is the problem. When you call deserialize, as I told you before, that said, when you are deserializing stuff, it never keeps its state. And if you are calling deserialize to something, to the first value, then you lose your old data. You cannot go back. This is it is just, you know, streaming all the stuff.
But you receive a string, right?
No, it is you just have a visitor and Serder call your visitor.
I mean, in theory, on the very top level, it might have a vector or a string, but underneath, when you register data.
Let's go to my presentation code, Wrocław, hacking Serder, and it was Serder problem, I guess. Okay, let's go here quickly. Let actually for a second let implement this guy. So I can show you what code is generated here. Let's check it. So what happens here? You have this deserializer, and this deserializer is provided by example by Serder.json, so some library, right? And if you go to this deserializer, okay, this deserial function is directly from the deserializer, right? And if you go to this deserialize, let's content deserializer, it's new. And where is this call? I'm looking for the deserialize call. Okay, here is the deserialize call. Let's go into that. Would it jump to this? No, it won't. So let's go to Serder. This is also a way because I know where it lies, or I think I know. We go to Serder. We go to some stuff. For example, let's go to enum content. Impl content, impl deserialize. If you go to this, look what happens. You are creating some visitor here, and you are calling this deserialize content thing. And if you just go to deserialize content, it calls deserialize any with the visitor. And visitor, if you go into this, is just a trait which is like, okay, you got bool. So you got bool, you can react to bool. You got I8, right? So this is what you deliver, but deserialize any is just a function which is implemented by server.json, for example, and the server.json would call those functions like, oh, here you have a structure, oh, here you have a map, oh, here you have a I8, and you need to handle that. But you don't have any access to the memory because it could be even streamlined for network and you can lose it. And this is why there is this content here, which is, keeping it intermediately. And I try to use what is called set the value, but set the value is, as I said, just this content extracted. So the result was exactly what I had server directly. So I needed to fork the server, but instead of forking whole server, I forked I don't know, let's check how many tokens do I have inside the CW value. By the way, the name is CW value, which maybe suggests it is only for Cosmos, but you can use it if you need a value without floating points. The reason why it is the name is because it's dedicated for Cosmos, and if you would need anything else from it, which is related to Cosmos, I am free to add this here, right? So, but it is, you can use it not only for this. So let's go with Toki. How many codes I do have? I don't know, 1,500 lines of code. So I do not need to maintain thousands or hundreds of code of Serda. I just small library to maintain, and I don't think there would be any problems with that. If there would be, then I would apply, but there are not many problems with Serda.json. So it's
5 comments, unbelievable.
Sorry?
And you can found a place for 5 comments.
Yeah. Yeah. It's and I'm pretty sure that's not my comment because in this fork I was almost only removing those lines. I did some cleanup of creepy warnings because this value, this crate was not updated recently. So yeah, set the value, which is just extracting the set the content.
So I am afraid we are quite short on schedule.
I know. I'm sorry.
So,
but that's questions. Pizza.
I have to force myself to be the last one to ask a question that is long overdue. You need to show us a unique and prove that it's not Manjaro.
Okay.
Oh! Sorry for that. This is Manjaro. I do not use this laptop. But I'm right now feel ashamed because I was sure I already started, but this is Manjaro, sorry. I was sure, but yeah, this is Manjaro, and this is why this works like this, probably. This is the reason.
Come on. Arch, but with nice GUI for installation.
It's not.
It's not.
It's not. Probably, I swear, Manjaro is the reason why I never more use laptop, because I have Manjaro on this laptop. I swear.
Okay.
On my desktop there is reasonable.
It's for Debian. It's a shitty package manager for Debian, right?
Yeah.
Yes.
Żebyście połykali w biegu pizzę, a dzisiaj wyjątkowo nie ma z nami Giny.
Yes.
Okay.
So.
Aha, przepraszam.
Nie, śmiało.
Jest ktoś, aby zacząć tutaj?
Chyba tak. So the thing is, we are short on schedule because we need to close our office, and we have pizza. So obviously we need to eat this first and then leave the office. One last, let's say, thing
Okay.
today is that we have 2 gift bags. So we do 1 question per talk to the audience, and who answers the question first gets the bag. So you want to think about your question, and I will ask mine.
Okay.
Sorry for putting you
I didn't think
in
about
this
that.
situation, but yeah. Okay. So my question is, how is the dedicated debugger for Hubris called? Yes.
Okay.
Nice.
I was not prepared for that, so maybe Is anyone remember? Let's make sure that it's not on the screen now. Does anyone remember what was the tool I used to show the whole path of the calling the call, in the was binary? Yeah, it was that.
Who asked for this question?
There's another one thing, very quick one. I don't know if you know, but like some time ago, like a year ago, we ordered Rust for Rust session books, and there are still 2 books which are lying on my shelf, which were not claimed. And please, if you know someone who was ordering the book with us and do not receive it, please, let him reach me, because if no one would claim those books, we would have giveaway, because I mean, they are not mine, and sorry for that, but I don't know.
Remember, it's not my fault that your pizza is cold, okay?
So yeah.
Okay, so to wrap it up, thank you all
Exactly.
for being here. Thank you all online, and see you next time.
Yeah.
Bye-bye.
And we are going for pizza and then some beer.